Good morning, everybody. This is Carl Griffith from Graybar. I'm the Director of Emerging Technologies at Graybar. One of my responsibilities at corporate marketing is data centers, and I'd like to welcome you to our G2 Talk webinar series. And today our discussion is going to be about digital lighting in the data center. Before we get started, though, some of you may not be familiar with Graybar, so I'd like to tell you a little bit about ourselves. We're a distributor. And our mission statement is up on the screen there. We, Graybar, help our customers network, power, and secure their facilities with speed, intelligence, and efficiency. In this particular case, the facility is a data center, and we're just very happy that you're with us today on our conversation about digital lighting. Before we get going here, a couple announcements, so to speak, that can help us through the webinar. This is going to be there will be a Q&A in the webinar, so you'll be able to type questions in the Q&A box that's on your screen. If you'll type your question in there and submit it, it will appear on our side. At the end of the conversation about digital lighting, we'll have a Q&A session there, and we'll go over all of those questions that are up there. And we encourage your feedback, so just type a question as it goes through, as we go through the presentation, and you get it, and we'll get it on this end. The first 50 people that log on and for our webinar will receive a cup of coffee via email. I know that sounds strange, but those first 50 people will get an email from Graybar, and in that email will be a coupon, an e-card, so to speak, that you can exchange for a cup of coffee at a major coffee chain in North America. So that's how that works. Our presenter today is Michael Clemens, and Michael's a value stream manager with Nlight and Sensor Switch. Those are two brands of a company known as Acuity Brands, and Nlight and Sensor Switch are control companies. And Michael's a subject matter expert when it comes to digital lighting and controls. I've known Michael for quite some time. He's spent many years of his life in and around data centers. He understands the nuances of the data center environment, and he's now in the lighting business and understands lighting and lighting controls. So we're just so glad to have Michael with us today. So without adding any more conversation, we'll just get right to the point here. Join me in welcoming Michael Clemens to our G2 Talk webinar today to talk about digital lighting in the data center. Thank you, Mike.
Thanks, Carl, and welcome. And thanks for joining us today, everybody. And thanks to Graybar for putting this session on. In the interest of time, we're going to get right to it. And as Carl mentioned, there's going to be some time at the end for questions. Today we'll be discussing digital lighting and its application for data centers. Specifically, we'll go over a few topics. Energy use in the data center, how much energy is being consumed by lighting and other components within the data center. The promise of LED. What is LED all about, and what can it provide? The quality of LED. LED offers some amazing benefits, and we'll discuss those. Digital lighting planning. What is digital lighting and how can I plan my space? Digital control strategies. What are the different ways to implement a digital lighting platform? Occupancy sensors and placement. What sensor technology is available to me and how should I place them in the data center? And finally, at the end, we'll talk about system costs and return on investment. We all know that data centers are notorious energy hogs. This is shown in the chart on the screen there. But at first glance, lighting may not seem like it's worth much attention when compared to the other really power-hungry components that are in the data center. And if you look at servers, represent about 40% of the total energy spend, and HVAC eats up about 30% of the energy spend. But lighting, at 5% here, it really represents something that you can address right now. It's the lowest hanging fruit within your control, and it can yield quick, almost immediate results. And with the advances in lighting technology, the time has never been better for lighting and energy upgrades. So why focus on lighting? As I said, it's one of the few areas that can yield immediate savings. Other systems require much more effort and are much more involved. Lighting retrofits are quicker and less costly than other changes. Along those lines, a lighting upgrade will not disrupt your work environment for very long, and the capital outlay is much less substantial than other systems. Better quality lighting provides a safer environment and reduces human errors. This is an important thing to know. Better lighting yields better work results, not to mention the safety factor, not only for the worker, but for the network and the data itself. Better lighting can improve uptime. In the data center business, we all know uptime is king. Nothing is more important than keeping the networks and the equipment up and running. We all know the cost of downtime. Poor lighting can lead to errors, which in the end will cost money for everybody. And finally, new technology has made lighting and controls much easier. LED lighting and digital controls have made upgrading lighting quick, efficient, and extremely cost-effective. It's never been easier to deploy a superior quality lighting system, and it all starts with the LEDs. So let's take a look at the evolution of digital lighting technology. In actuality, LEDs have been around for about 50 years. We've seen them in signs, we've seen them in traffic lights and railroad signals. They moved on to decorative accents in the 1990s and only really started to become commercially available or commercially viable lighting sources very recently. You know, there's an annual trade show every year in the lighting industry called Light Fair. I was there back in April, as was Acuity Brands. This year was held in Philadelphia, and walking around that trade show floor, you'd think that there was nothing but LED anymore. There are quite literally hundreds of LED lighting manufacturers out there. That's how fast this technology has come on. I mean, 3 years ago, LED was relegated to very expensive decorative or specialty fixtures. Well, that's no more the case. LEDs are here, and they provide outstanding light in virtually every type of application, and the data center is no exception. This technology is moving faster even than industry experts had predicted. Sales are exceeding expectations. LED efficiencies are up, and the price is really dropping, so it's a very good time to get on board with LED. As LED becomes more prominent, it's a good idea to understand the benefits that LED technology promises to bring. And there are 3 things to look at here. The first is the source. Here we're talking about the laser emitting diode itself. That's what LED stands for. LED is an extraordinarily efficient technology. The light it emits versus the power required to drive that light is beyond any other commercially viable technology. It also is extremely long-lasting. Today, it's not unusual for LEDs to be rated for 50,000, even 100,000 hours. Compare that with the best fluorescent on the market, which ranges about 20,000 hours, and many are even less than that. What's more, it's a green technology, meaning there's no mercury in the LED that will complicate the disposal. It's also green in that it helps reduce energy consumption. Then there's the LED in the fixture, or what we call the luminaire. LEDs can be arranged together inside a luminaire such that they present a really striking aesthetic appearance. They can be directed and diffused, and there's no more ugly fluorescent tube visible. Also, as we'll learn shortly, the lighting quality from the LED fixture is really second to none. Then there's finally the LED fixtures as part of a system, a digital system. And since they are digital, it's now feasible to build them into an intelligent, highly adaptable system. As we'll see as we progress through this presentation, these systems are simple to install and becoming more cost-effective every day. So, as we make the switch to LED, there are some significant benefits. Those tube-style fluorescent lamps, the T12s, the T8s, the T5s that you see on the top left of the screen there, those go away, and they're replaced by the LED board, which is on the top right side of your screen. This is actually being helped by legislation. As of January 1st of this year, T12-style fluorescent lamps have essentially been discontinued, and they're very difficult to get, except for people who already have stock of them. And you've seen these. These are the large fluorescent tubes that you've seen in many spaces, including in lots and lots of data centers. New LEDs deliver better light and are virtually maintenance-free, as we said before. Then there's the change to the ballast. Fluorescent fixtures have a ballast in them, and that's shown on the left here, and that is wired via traditional wiring with wire nuts, as you see there. New LED fixtures, although most of them are still AC powered, have LED drivers in them that do AC-DC conversion, but the control system is interfaced via a Cat5e and a Cat6 cable. So it's simple plug and play, and it really gets into the realm of datacom contractors and data center people. Some additional benefits of LED versus fluorescent include reduced heat. Now, we all know this is a major issue in data centers. Right? If you can reduce the heat in the space, you also cut down on the cooling costs. LEDs direct their heat out of the space, especially when they're in drop ceilings, right? They direct that heat into the plenum area. Fluorescents direct their heat into the space, so you got to accommodate for that with your cooling system. There are also generous utility rebates for installing LED systems. I mean, some of these rebates can total up to 50% of the total cost of the project. And the U.S. Department of Energy claims that in 2008 they gave away $3.1 billion in rebates for LED systems. And they estimate by the year 2020 that total will go up to $12.4 billion. I mean, so clearly there are some really major benefits for LED systems. But they don't stop there. Perhaps the largest incentive to switching to LED is in saved maintenance costs. LED is essentially, as I said, a maintenance-free system. I mean, a typical LED luminaire will last 50,000 hours, and that's roughly 4 to 7 times more than the average fluorescent lamp that's out there. To further illustrate this point, if the fixture is on for 10 hours a day, 365 days a year, then the typical LED will last 13.7 years. That's a long time. Now, when you add in digital controls on top of that, useful life can be extended an additional 20 to 100% or more. Savings like these have never been seen before in the lighting business. It's really, really incredible. But all LEDs are not created equal, and when you add controls to the fixture, you can really start to deliver what we call the right light. That is, delivering the right type of light, meaning, is the light fixture delivering light that's right for your application? Is it a spotlight? Is it a downlight? Is it a volumetric light designed to fill the space? The right type of light is important, and it becomes really easy to do with digital controls. An example of this is the difference between parabolic fixtures and volumetric fixtures. We've all seen these parabolic lights in various places, including data centers. They look like your grandmother's ice cube trays from years ago, right? It's got those cross patterns in it. Well, the issue with parabolic is that it creates hot and cold areas of light. Light is not evenly dispersed throughout the space. With volumetric fixtures, light is reflected off its surface and evenly distributed throughout the space. And the effect is really startling to see. I mean, if you have those old parabolic fixtures, it's really time to think about upgrading those fixtures. Secondly, are you delivering the right amount of light? Right? Not too much, not too little. This is very important inside the data center where, as we know, poor lighting can lead to errors. Is the light hitting the right place? Meaning, is that fixture delivering the light where you want it and not where you don't want it? Delivering light only where you want it cuts energy consumption and improves the workplace environment. And finally, is light being delivered only at the right time? If the lights are on when no one's there, that's wasting energy. If the lights are off when you need them on, well, then that's pretty inconvenient for users. And one last note, actually. Replacing fluorescents is not as simple as replacing the old T12, T8s, T5s lamps with the tube-shaped LED. There are manufacturers out there that will tell you that it is as simple as that. Don't listen to them. LED lighting is a new science, and it requires a different approach than simply swapping lamps. And we'll discuss that in a minute. That brings us to the quality of LEDs. LEDs are by nature a directional light source. That is, they shine in one direction. Fluorescents are by nature an omnidirectional source. So they shine in a 360-degree pattern. You can see that on the left and right-hand side of your screen. So by their natures, you can see that how it's virtually impossible to simply swap out the lamps and hope for a high-quality light source. Light from LEDs must be bent and shaped and to deliver the light where we want it to be. is done by adding reflectors and refractors inside that fixture to direct that light where it should be. That's why it's important to select an LED fixture manufacturer that focuses on the quality of the light. Quality manufacturers will build the luminaires to make optimal use of the LEDs, and they'll make their solutions to fit specific needs. Companies that focus solely on controls and leave the lights to others, well, they're only giving you half the story. That brings us to planning the lighting in a data center. As you know, many data centers just leave the lights on all the time. We've seen it many times. That wastes energy, and as you know, it's very inefficient. Conversely, others just leave the lights off and rely on users to switch on and off lights as they use the space. Again, this is very inefficient because people always leave the lights on, right? Or they forget to turn them off, right? With a little forethought, your data center can become very efficient, and it all starts with the ceilings. The majority of spaces make use of drop ceilings. While this is a good way to do it if you're starting from scratch, if you have an existing ceiling, your rows may not perfectly align with your lights. Now, for this example, we're going to assume that this is a new installation and that you can center your lights on your rows. As you know, TIA 942 suggests that the use of alternating hot and cold aisles, right? In this illustration, you'll see that the blue aisles are cold and the red aisles are hot. And this ceiling allows us to position our lights where the work will be performed. Drop ceilings are great because they allow for either 2x2 or 2x4 fixtures. And doing it this way is ideal for controlling these fixtures either in a group or individually. It also allows any excess heat from the LEDs to be vented up into the plenum, reducing the heat in the space. For those areas that have higher ceilings or hard ceilings or inaccessible ceilings, a typical approach is to use 1x4 strip fixtures. Here we have the same data center as we had on the last slide, same hot and cold aisle orientation. But in this case, with the strip fixtures, it actually may even be easier to locate the fixtures where you want the light. Controls can then be overlaid on top of that and controlled either in groups or individually. So now that we've installed our luminaires, let's talk about adding controls. We know that lighting controls offer many benefits. It saves energy versus standard switching, right? We touched on this before. If you rely on users to switch on and off lights, you're going to be disappointed. Reduces heat in the data center from overlighting. Lights are on less, so they're generating less heat. It lengthens the life of the light fixtures, so that 50,000-hour fixture, right, can now last many more years because you're turning it off when there's nobody in the space. It provides enhanced user experience, meaning better light for better performance. And as we know, it can help minimize downtime due to errors. There are essentially two primary strategies for lighting controls. The first one is centralized intelligence, and the second one we'll talk about is distributed intelligence. As I said, the first strategy is centralized intelligence. With this type of system, intelligence is located at a single location. Typically, there is a central panel or a rack of equipment that's placed inside a telecom room, or it may even be in the data center itself. Now, all the brains of the system are now in one spot, and any interaction with the system requires constant communication with the central controller. Distributed devices like occupancy sensors or photocells or even manual controls on the wall, they don't have any individual memory in them. And therefore, if you lose control or lose communication with the central controller, your space is not going to function properly. Often, this type of system provides centralized power to the devices as well. So all sensors, all wall controls, and maybe even the fixtures themselves are powered from one central spot, and sometimes they're even powered over Cat5e cables. Since everything is tied back to the central controller, the system does not lend itself to modular build-out. There's no easy way to start with a small space and build it out as your network grows. So it's basically an all-or-nothing kind of thing. So let's take a look at our sample data center again. It's the same one we had in the previous slides. Here we have a centralized system. It's deployed with occupancy sensors on every fixture, as you can see with the orange dots on every single fixture that's in there. And this is often the case with these types of systems. This provides what they claim is the ultimate in granularity for control, and enables what is often referred to as follow-me lighting. Right? As the person enters the data center, only those lights where the person walks are illuminated, and all the others stay off. The lights here are powered via the Cat5e cables, so there's no AC power required in the ceiling to power the lights. All DC power conversion is performed at the power engine, and that power engine, as you can see, is over on the left-hand side of your screen. A couple of things to point out here. Cat5e, or Cat6 if you're using Cat6, is really a poor electrical conductor. I mean, each cable is only capable of transmitting 20 watts of power over the standard 100-meter length. So most fixtures, even the most efficient ones out there in the market, draw a minimum of about 45 watts. So as such, each fixture would require 3 separate Cat5e cables, home run from that power engine in the telecom closet, all the way back to the fixtures. That's a lot of cable. So in this space here, it's got 40 fixtures in it, that's 120 Cat5e cables, home run back to the power engine in the telecom closet. That's an awful lot of cable. What's more, this power engine that's there, it really represents sort of one single point of failure, right? If the engine goes down, not only are you losing your lighting controls, but since that power engine is powering your lights now, you're losing your lights as well. Also, since we're doing the AC-DC conversion in one area, the elimination of those AC-DC conversions removes heat from the space, but it moves it to where the telecom closet is, right? In fact, the engines are sometimes very, very inefficient, and sometimes as much as 70% efficient versus LED, which is and the drivers that are in them, which are almost 100% efficient. And by eliminating the AC-DC conversions at the fixtures, you've essentially just moved it from one spot to the other, the heat generation in that. Each of these fixtures also requires not only a sensor, but also a network interface device to work properly. So there is most likely 2 extra components on every one of these fixtures in this configuration. A lot of equipment. So let's explore a distributed intelligence system. In this system, all devices contain an embedded microprocessor with a unique ID and have controls built right into them. There's no extra components per fixture. Simply connect a single Cat5e cable, connect all your fixtures and controls into space, and you're done. It's really that simple. All control decisions are performed locally, so there's no need to maintain a permanent connection to the network. If you are networked and you do lose that connection, well, the spaces are programmed to work as they're supposed to work, so there's no downtime. Your controls are still working, your lights are still working, everything's still working. The system offers simple plug-and-play interoperability simply by plugging in your Cat5 cable, and essentially it self-commissions. And it's also capable of operating in a standalone mode, meaning you can start by building out a small data center or a small room, and you can expand that as your network expands. So here again is our sample data center. We have the same layout, same fixture layout, but instead of the multiple Cat5es per fixture as we had in the last one, each fixture is now powered via AC power, right? AC power is almost always present in the ceiling, so we're making use of the AC power that's in there. A single Cat5e is daisy-chained throughout the space, connecting all the controls and the fixtures. Occupancy sensors here, again indicated by those orange dots, are strategically placed throughout the space to pick up motion and turn on lights in groups. And this drastically reduces the number of sensors required, and it lowers initial costs. Now, if you want to network this space, all you need to do is run a single Cat5e from the data center to the network bridge, which looks like an ordinary data bridge in many cases, to connect this space to the building network. And again, this model represents a 65% reduction in the number of sensors required versus the previous model. However, if a sensor per fixture model or that follow-me model is what you want, well, then the microprocessors that are in these fixtures, they can do that as well, right? That's not a problem for this. So the distributed intelligence model also dramatically reduces the amount of Cat 5e, right? I mean, we talked about having 3 per fixture and 120 coming out of that room. In this model here, we basically have one single Cat 5e coming out of this data center back to the network. So it's a substantial reduction in the amount of cabling required. The distributed intelligence model has many benefits. One is granularity of control, right? Fixtures can be controlled in groups or they can be controlled individually. It reduces the number of control components necessary versus the centralized system. It improves the overall lighting quality. Fixtures make use of the embedded digital circuitry that's in those fixtures, and they're optimized for that space. It's also future-proof. Devices and luminaires can be added and removed with ease. The system will self-recognize that there's been a change in it, and it will resync all devices in the control zone. And it also saves energy. The processor, the microprocessor that's in there, knows the degradation schedule, the LED, and how the LED and driver is going to perform, and it will ramp power to save energy. And we'll talk about that on the next slide. So, because these are now smart fixtures, they can do things that no fluorescent fixture could ever do. And one of those things is what is called digital lumen management. So, inside each luminaire, as we said, is that microprocessor. Well, that processor is the brains of the fixture, and it knows the performance of its LED and the drivers. With fluorescent fixtures, lighting designers, as you can see on the left-hand side of the screen, lighting designers must take lamp degradation into effect when they're designing a system. That is, they know that the brightness of the fluorescent lamps they put in on day 1 will not be the same brightness as those lamps are at year 5. Therefore, they put in lights that will provide adequate lighting at year 5 when the lamps have degraded. In effect, they're overlighting the space from day 1 to year 5. That's wasted energy. Where with digital lighting, what we can do is the luminaire is smart enough to know the degradation schedule of the LEDs and the drivers. So at day 1, instead of powering at 100%, we power that fixture at 80%, and as time goes on, what we do is we increase power to those LEDs to provide a constant light output. In effect, we've reversed that curve, and we've saved a lot of money, 20% from day 1. That's one of the things, and it illustrates the power of digital lighting. Okay, so now that we know that the true power of digital lighting, right? It's important to reiterate the fact that the quality of light, not control of the light, is the most important factor. We know that poor lighting leads to poor results. So when you're selecting a digital lighting system, choose a manufacturer with a proven reputation for quality. I mean, controls, and this is coming from a control guy here now, controls may help you put the light on your work at the right time. But if the light it's controlling is an inferior quality of light, then even the best control system out there is not going to give you what you need, and it's not going to compensate for poor quality light. So therefore, lighting quality is really the most important factor to consider in this application. All right. Let's talk briefly about available sensing technologies out there, because as we know, the best way to optimize your data center is to put the occupancy sensors in there. There are 3 basic detection methods for occupancy sensors. The first is passive infrared, or PIR. The second one we'll discuss is ultrasonic technology. And finally, we'll talk about acoustic technology. All right, passive infrared. So as the name suggests, passive infrared is a passive technology, meaning it doesn't emit anything into the space. It simply looks for heat in motion. What it does is sense the difference in heat between moving people and the background. It's important to note that PIR does require line of sight to operate correctly. Therefore, the racks and the cabinets and the other obstructions inside the data center can limit its detection. It'll become important to choose the right type of PIR sensor and position them properly inside the data center. On many PIR sensors, you can adjust the field of view and adjust its detection pattern. It's also important to note that PIR sensors are most sensitive to lateral motion, meaning it'll pick someone walking across its collection beams better than it will someone who's walking either away from it or walking towards it. Also keep in mind that sensitivity to movement decreases with distance. So the further you get away from the sensor, the less sensitive it is in picking up your motion. And finally, and this is really pretty critical, avoid mounting PIR sensors near sources of heat. Excessive heat can limit its detection capabilities. But if your data center is adequately cooled, a good PIR sensor will have no issues, even in the hot aisles. Next is ultrasonic technology. Ultrasonic sensors emit high-frequency sound waves into the space. That's different. It's an active technology, unlike passive, where it's not emitting into the space. Ultrasonic emits a high-frequency sound into the space, which is then reflected back to the sensor. If the sensor detects a change in frequency in these waves, it turns the lights on. It triggers the lights to turn on or turn off. Ultrasonic sensors can see around obstacles and are more sensitive than PIR, but they can't adjust the field of view. And unlike PIR sensors, ultrasonic sensors are most sensitive to people walking directly towards or away from them as opposed to across. All right? One thing to note about this, too, is you should avoid mounting these near airflow. Should not be mounted anywhere within 6 to 8 feet of an air source, nor should they be mounted anywhere on a surface where there's excessive vibration. And that's going to be important in a data center as well. The last technology is acoustic. Acoustic technology, or microphonics as it's commonly called, uses a microphone to listen for sounds caused by typical motion. It then uses advanced signal processing to distinguish between the white noise and sounds indicative of human occupancy. Acoustic detection is not a standalone detection method. It's almost always used and combined with PIR to produce a very reliable method of detection for many applications. PIR sensors with acoustic and PIR are called passive dual technology sensors. So, which one's best? What's the best detection technology for data centers? Without a question, it's PIR only. And there are a couple of important reasons for that. Data centers are noisy environments. The hum of servers and the AC equipment is too much for ultrasonic and acoustic technology, and it can cause false trips. We certainly don't want to turn the lights on or turn them off when they're not supposed to be. Vibration is an issue. The equipment in the room, as well as the HVAC system, shake things inside the space and would also trigger false ons. So the best solution is a strategically placed PIR sensor, and correctly placed away from heat, PIR will provide the best detection technology. Okay. Now that we know a little bit about the sensor technology, let's look again at our sample data center. Here you'll notice that the sensors are placed in a pattern to cover walking motion in groups, and we're talking about groups and aisles here. As seen here by the orange dots, they're strategically placed throughout the space and control a group or multiple groups of fixtures. That can be seen by the dotted rectangles. If you can see the dotted rectangles that are in there, that indicates the group of lights that they're controlling. That is to ensure that there's adequate light in the space for someone who may be on the edge of the detection pattern. Okay? Because of the placement of the sensors, only those lights where the person is will be illuminated. Now we can also add manual controls to this as well for temporary override. Okay, let's talk a little about sensor per fixture now. Here we have the same data center, but we're talking about a sensor per fixture model, right? A single sensor on each fixture controls that individual fixture. Because each fixture is controlled individually, there's often no need to group these fixtures together. However, as we saw in the past few slides, this model uses 65% more sensors than other models, especially the groups and aisle model. That's a lot of upfront cost. Also, since the sensor is on each fixture, the PIR detection range of the sensor is typically smaller than that of the larger sensors. Because of this, adjacent sensors and fixtures may not pick up motion. And you have to ask yourself, will this one luminaire that's being turned on by that one sensor, will that be enough for a person to perform their work? Well, that really remains to be seen. Okay, let's talk about benefits of groups versus per fixture. So just as PIR is the preferred sensing technology for data centers, arranging those sensors so that they operate in groups of fixtures is probably the best approach for controlling a data center. And there are a few reasons for that. The first is lower initial cost. Providing a sensor for each fixture, while it may appear to be the best choice due to granularity, can increase the initial cost a lot. Sensor per fixture designs require many more sensors to cover the same amount of space. This lengthens the return on investment and can in some cases even be distracting for workers in the space because the lights are cycling at random times. Secondly, fewer sensors require less programming. Highly granular systems require more programming so that the constant level of light is maintained in the data center so that the workers can adequately perform what they need to do. It's not as simple as just keeping one fixture on. That one fixture, as we said, may not provide enough light to perform the assigned duties, and so you may need to keep multiple fixtures on. And by having individual sensors on fixtures, that complicates the programming. Finally, fewer sensors translate to better heat isolation and ultimately better detection. Sensor per fixture installations place a heck of a lot more sensors inside the aisles, closer to the hot equipment. The heat generated by that equipment can interfere with the PIR detection. It's best to move the PIR sensors as far away as possible from the sources of heat. Okay. Let's not forget about dimming, though, right? And these are LED fixtures, after all. So it's also important to note that data centers don't always need to operate in on-off mode. LED luminaires are designed to dim. You may find that it's beneficial to dim the fixtures to a minimum level instead of turning them off completely. Or you may want to turn some of them off and leave some of them on, and leave some at a minimum dim level. There can be many reasons for this, and those include safety, security, egress. The curious thing about LED is the fact that they become more efficient as they dim. And that's not the case with fluorescence or really any other type of lighting out there. So if you dim a fluorescent fixture to 50% light output, you're not saving 50%. In fact, that fluorescent fixture is still consuming about 75% power while only providing 50% light. Well, the reverse is true for LED. 50% light output is achieved at 40% power consumption. That's why it's so popular to dim LED fixtures. In fact, there are many new standards and coming out, and even codes that are currently in the works that will require dimming in certain applications. And that will really only serve to hasten people's adoption of LED. Okay, finally, let's take a look at some system costs. Here are our assumptions, and these are pretty typical of a standard lighting system. So we have 9 luminaires, identical maintained illuminance. Our controls options include dimming and occupancy sensors. We expect that this system will last 15 years, and it's going to be on for 3,500 hours a year. Our labor is charged out at $80 per hour, and we pay 10 cents per kilowatt hour. Right? So if you look at the left column where it says fluorescent T8, no controls, first column is a bare bones fluorescent system with no controls. So that's our baseline model. The second column uses the same T8 fluorescence, but then it adds in controls. And finally, the third column represents a true digital lighting system. As you can see, the controls add cost to the initial price, which is shown in the second column. But they do not save energy and maintenance costs and lamp replacements. The digital system, which is on the far right, is more expensive on the material costs, but only slightly more expensive than the base model for labor costs and less expensive than the fluorescent model with controls. That's because with digital, we don't have to worry about installing additional components and having costly dimming ballasts and other components. The real savings, however, come in when energy savings and maintenance. Since LED is more efficient than even the best fluorescent out there, the energy cost is lower. And what's exciting is the fact that lamp replacement costs are zero. You'll never spend a dime on replacing lamps. And this is all due to the longevity of the LED boards. So in total, over the lifetime of the system, and the LED system represents 13% savings over the baseline model. And the baseline model that has no controls at all. So bear in mind that this cost model doesn't even begin to factor in the intangible things like the enormous benefits that you can get from a digital system. Well, my half hour is up. In conclusion, I hope that I have expressed the power and the economic benefits of LEDs and digital lighting in data centers, and we'll open it up to questions now. Again, I thank you for your time today.
Thank you very much, Michael. Those that have questions, you can type your question in the Q&A box on the screen that you're looking at, and we'll respond to those questions. While we're waiting for them to come in, I have a couple comments, Michael, if you don't mind. One is the slide early on in your presentation talked a little bit about utility rebates available to data centers that want to upgrade their lighting. I wanted to confirm that that is actually true. I know here in St. Louis, where our office is, Ameren UE is offering rebates. They have about $20-some million available. At the last AFCOM meeting that I attended at Savvis, Ameren UE spoke about those rebates being made available to data centers, and lighting was definitely one of the areas that Ameren was willing to offer some money for projects that have to do with lighting. I can assure you that that occurs with most utilities around the country. So if you're going to do a lighting project, make sure you check with your Graybar rep and have some communications with the utility to see how they can help you fund your project and reduce some of the cost. Now, the second thing I wanted to make mention of is that Graybar can help you with an audit. So if you don't know what your baseline costs currently are for the lighting inside your data center, we can help you establish what that baseline cost is with an audit. And then we can use modeling tools to determine what the new cost would be when controls and LED are added. And we can provide you with some documentation that can show you what your energy cost reductions will be. As we compound them year over year, you can see how much that energy savings annuity can be for you and your data center. But we will be more than happy to help you with an audit. The other comment I wanted to make, Michael, about lighting in the data center is that there's more lighting than just on the raised floor. And we really appreciate your examples about how lighting works on the raised floor in the data center. But lighting is all over a data center, whether it be outdoor on perimeter lighting around the data center, whether it be in surface parking lighting for the people that work at the data center or for guests, or whether it be in the office space that's associated with the data center where people work when they're not on the raised floor. All those areas are lighting, are places where lighting is required, and LED can provide huge savings. One of those areas that it can provide big savings is outdoor on that surface parking lighting. If it's lit up at night, LED can save a tremendous amount of money. So those are just a few comments I had about LED from a data center perspective. Did you want to add anything to that, Michael?
No, I mean, just the fact that LED specifically to outdoor. I mean, LED. I think the quickest adoption for LED is coming on the outdoor side, and so we've seen the adoption of LED fixtures on the outdoor side grow tremendously over the past couple of years. And in fact, almost all of the solutions that we're selling these days are LED. So that's a very good thing to note, that outdoor is a good place to get some savings with LED.
A couple people have commented and have come in, and I see here on the screen. They want to know about whether this presentation is made available, and the answer to that is yes. If you go to graybar.com and you click on the G2 Talk webinar icon, you'll see a link to our archive, and all of our G2 Talk webinar series are archived, so you can go up there and get a copy of the presentation. You can review it again. So for those people that ask those questions about is the presentation available, the answer to that is yes. If you have a question, get it in here, because if we don't, we're going to close this off. Let's see, is there anything else? Julie, we thank you for your comments about the good presentation, and we appreciate that. We thought that lighting would be a good topic to discuss for data centers, and Again, the copy of the presentation will be made available to you at graybar.com. If you go to the G2 webinar icon there and click on it, the archive will be made available tomorrow. Everything will be archived up there. In fact, you can go up and look at previous presentations as well. Any other questions? And if you'll type them in quickly, we'll try to get to them.
Hey, Carl, there are a number of questions on the line here.
I don't see them.
In your screen?
Nope. Go ahead. Bring them up.
Go ahead and read them.
Greg. Yeah, go ahead and read them.
The first one is, are these systems in 120 or 270 volts?
The answer to that is both. So it's 120, 277, so it'll operate in either 120 and 277 volt.
Okay, great. William asks, who is designing these systems and who is installing?
The answer to that question is it varies, right? I mean, typically these systems will be designed either by lighting designers, and they would be installed by electricians. But important thing to note about that is since they are low voltage, right, especially the control system, there isn't any reason why datacom contractors and IT people can't install the low voltage portion of the control system on that. Even if the fixtures are AC powered and you need an electrician to install the fixtures, the control system is something that can be installed by low voltage contractors.
I'd like to add to that, Michael. Graybar can help you with a lighting project you want to do in your data center. We can arrange, we can arrange for the audit. We can work with you to make sure you have a proper design from a lighting professional, and we can clearly recommend people to do the installation, or we can use the current staff that you have that does your electrical work in your data center. So we can talk about that, and there's lots of different options. I would just encourage you to give Graybar a call. We'd be more than happy to come in and chat with you, and we'll make sure that all the resources that we have available can be made available to you for a proper design and installation. We're here to help you any way we can with that. Greg, are there some other questions?
Yeah, we've got a whole line here. Nelson's asking, is it available for residential applications?
The answer to that is it will work in residential applications, but the primary focus of these systems is primarily commercial. But there isn't any reason why it couldn't operate in residential applications.
Alrighty. Would you recommend interior lights on occupancy sensors to also be routed through lighting control panels for time control?
You can do it that way, but what's nice about a lot of these systems is you can eliminate the panel entirely. Since these are smart devices, the way these are networked is you basically take your Cat 5e cable and you connect it back to a device which we call the gateway, and that gateway is essentially the brain. So you eliminate that panel. That panel is not required anymore. And in that gateway, you can set, it's essentially a time clock. And from there, you can set schedules and time schedules for your lighting system. So I would recommend that you do it that way versus putting it in through a panel.
Okay, great. There's another question here. Oh, Carl?
I was just going to say, from the question previous about residential applications, lighting control is important in residential lighting as well, just like it is in commercial. Residences that currently exist have a myriad of type of lighting involved in them, whether they be old fluorescent fixtures, old incandescents, or whether they're using curly fluorescence, compact fluorescence, etc. So residential lighting controls can be engaged in residential lighting. Again, if you'll contact your Graybar representative, we can put you in touch with the people that can help you with the residential design, or we can probably even recommend some things that in the DIY world if you're interested in that. But yes, I just wanted to make sure we didn't miss the opportunity for lighting and lighting controls in residential. We can definitely help with that. Okay. Go ahead, Greg.
Yeah, here's another question. In a sensor-controlled environment, does the constant turning on and off of the lights cause a negative impact on the life of the LEDs?
Not at all. In fact, that's one of the nice things about LEDs is it doesn't matter how often you're turning the lights on and off. Typically, for most sensors, we set the time delay to about 10 minutes, so that it's more of a distraction more than anything else. But LEDs are designed to dim, and they're designed to cycle as many times as you want. Unlike fluorescent lamps with the ballast, where if you cycle them on and off too much, you're damaging the ballast, and you can damage the lamps as well. LED, that's not a problem at all, so you can turn them on and off and dim them as much as you like.
Okay, here's another one for Bob. He asks, I have observed premature LED lighting failures with traffic lights and indoor applications. Are there any guarantees provided to cover premature failures?
Well, our LED fixtures and our system is guaranteed for 5 years. And so as far as premature, what's nice about the Acuity solution anyway is the fact that those LED boards are modular. So any fixtures that are Acuity fixtures, those boards can be swapped out if in fact there is a failure on that, even though the likelihood of a failure is very low.
Okay, great. Robbie has a question here. He asks, will the electrical engineer require a certified electrician, or can a low voltage cable guy install the complete system?
Basically what's going to happen is for the line voltage side, the electrical side, you are going to need to have an electrician install the fixtures. So the fixtures are still going to be AC powered. The control system is totally can be installed by a low voltage contractor. I mean, it is only 12 to 24 volt DC, so it's just a matter of running the Cat 5e cable and connecting up the components. But the fixtures themselves are powered via AC. So you need an electrician.
And then also on that same comment, will the cabling manufacturer warrant the C5E or the C6 installation?
Again, that's going to be up to the individual cabling installer, but the system itself, as I mentioned, is guaranteed for 5 years.
Okay, great.
One of the comments about the AC power, I just want to bring it to the attention of the folks on the call. When Michael made a comparison between a centralized control kind of function versus one that's distributed, clearly we're advocates for distributed systems because we believe that central point of failure could be problematic. The other thing that we need to consider, though, is the AC distribution. If you're planning to upgrade a data center, that electrical facility is already available to you. If you're going to take out a current fixture that's loaded with T12s, for example, and replace it with a fixture that now has LEDs in it, that electrical facility is already available. So there's no reason to abate that electrical facility in order to run a low voltage system to provide power to the fixture. So we need to consider all the costs associated with this particular project, and abating the AC that's already available there would be an unnecessary cost in my opinion. So I think the prudent thing to do here is use the AC facility that's already available to power the fixture, and then use the low voltage controls that are available in order to handle the control. So you think of it as two systems, one for power, one for control. Now, I don't know whether Michael agrees with me on that or not, but that's just one of the costs that we have to consider when we install make the installation. So that's my 2 cents on that, Michael.
Yeah, absolutely. I mean, like I mentioned, the AC power in the vast majority of cases is already going to be in the ceiling, and making use of the AC power is ultimately in the end going to reduce costs instead of running new cables in the ceiling and basically not using what's already there. The other thing to mention is that the vast majority of the fixtures out there are AC powered fixtures, right? So if you want a high quality light fixture or luminaire, then the odds are that the best ones are going to be AC powered ones and not DC powered fixtures.
Right. Well, we're running way over time on this presentation. This is how good it was. The questions have been outstanding. If you submitted a question and we have not answered it, we will answer that for you via email later today. The other thing is, people have asked again about where they can get the presentation. Graybar.com. Go to graybar.com, click on the G2 Talk webinar logo. You'll see a link to the archive. You can go to the archive and get to the presentation. If you're talking to your Graybar guy and you want a hard copy of this, just talk to them and we'll be happy to email it to you that way. But it is archived up on graybar.com. I wanted to make sure if you're the first 50 persons to be on the line, you'll get a cup of coffee. Watch your email for that. If you had a question and we didn't get to it, watch your email. We'll respond via email. Michael, awesome presentation. Good information for people that have the data center. We thank you for your time today. All that you attended this webinar. We apologize for running over here 15 minutes, but it was a good content and good questions. We didn't want to cut it off too short. You all have a great day. When it comes to lighting in the data center, give your Graybar sales representative a call. We'll be happy to work with you and get all the right resources that you need in order to do a lighting project at your data center. Thank you very much for your time. We'll see you next month for another G2 Talk webinar concerning data centers. Have a great day.
Thank you.